Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of vectors as forces. So as per the problem, resolve a force of 10 Newton into two forces perpendicular to each other such that one component force makes an angle of 15 degrees with the 10 Newton force. Now we are not given the direction of the 10 Newton force. We are just given that one component force makes an angle of 15 degree with the 10 Newton force. So for the ease of analysis, we can assume that the component force that makes an angle of 15 degree with the 10 Newton force is a horizontal component, that it's acting in the horizontal direction. So we can show our diagram like this. So this can be the component that we assume that is acting in the horizontal direction. So let's assume it's vector C1 and at an angle of 15 degrees with this component is the given 10 Newton force. Now the other component will be perpendicular to C1 or vector C1. So the other component can be shown as, so this can be labeled as vector C2. So we have to find vectors C1 and C2, which are the components of the given 10 Newton force. So for that, we'll have to draw a vector triangle for vectors C1, C2 and the 10 Newton force. So we'll arrange C1 and C2 vectors in tip to tail or head to tail format because C1 and C2 vectors are perpendicular to each other. So together they will make a right angle triangle. And the 10 Newton force will be the hypotenuse in this right angle triangle. So we'll use this triangle to find the magnitude and direction of C1 and C2. Now since this is a right angle triangle, we can use SOHCAHTOA to find the length of the horizontal side, which is the adjacent side for the 15-degree angle, and the side length represents the magnitude of vector C1, and the vertical side is the opposite side for the 15-degree angle, and the length of that vertical side represents the magnitude of vector C2. So let's start by finding the magnitude of vector C1, and for that we'll have to use the cos ratio because the formula for cos is adjacent over hypotenuse, and the side that represents the 10 Newton force is the hypotenuse. So the adjacent side length is the magnitude of vector C1 and 10 Newton is the magnitude of the hypotenuse or the length of the hypotenuse. So now we have to isolate the magnitude of C1, so we can cross multiply the 10. Now we can evaluate 10 times cos 15 degrees. So I get 9.66. and the unit is Newton. So this is the magnitude of vector C1. So vector C1 is equal to 9.66 Newton. That's his magnitude. And the direction is 15 degree with the 10 Newton force. So this is vector C1. Now we can find vector C2. So we'll start by finding its magnitude, and for that we'll use the sine ratio. The formula for sine is opposite over hypotenuse. So the opposite side represents the magnitude of vector C2. Now we can cross multiply the 10. Now we can evaluate 10 times sine 15, which is equal to almost 2.6. And the unit is newtons. So this is the magnitude of C2, and now we can write the vector C2. So the magnitude is 2.6 newtons, and the direction is perpendicular to 9.66 Newton force. So the direction of C2 is perpendicular to C1. So we are writing the directions like this because we are not given the direction of the 10 Newton force. We only know that C1 makes an angle of 15 degree with the 10 Newton force. So that's why we use that as a direction for C1. And for C2, we know that it's perpendicular to C1. So that's why we are using that as the direction for vector C2. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.